Okay, so let me start my part. My name is Shatalin. I'm working at JetBrains. I'm a team lead of MPS project, and today I'm not going to talk about MPS. I would rather talk about another project which we recently started and prototyped within the MPS team. That's biological knowledge base project, and we would like to continue developing that project in the future. So let's start first of all with the project requirements we had, or we currently use, right? So as I said, this should be a knowledge-based project. So the first and core part of or a brick in the project is the DSL, which may be used to express the knowledge facts within the biology research space, right? So we have to create this DSL, design this DSL, and use this DSL in order to introduce new facts into the knowledge base. Second subsystem of the project is a query language. Once you have a knowledge in the base, you probably have to get the possibility to access it. So the query language is quite complex. It should probably return results in some relevant sorting order and so on. And I will talk about it a little bit later. And another requirement which we have for a project is that we would like for each fact in the knowledge base, we would like to have a trace from this fact to the original information source. For example, an article which was published somewhere and actually prove this this fact or was used to derive this fact. And even more, we would like to introduce this knowledge base with the actual research process. So the person doing the research have to be able to plan and log the data of the research within the system and log it with the fact which would be facts which would be later derived from the research. So let me start with the first part of the project, a DSL for expressing the facts. There is a biological expression language which was developed before. The biological expression language, or BEL, is a language for representing biological observations in computable form. That was actually developed by the several projects in the past. The first project is BELIEF project from Fraunhofer Institute. I'm not sure what is the state of that project now, but they do some job in the area of the similar space. And another project is OpenBell. Both projects mostly does or target the same goal. They would like to take articles available in the biology space and somehow reconstruct the facts, the knowledge facts from the articles, express them using the Bell language, and actually form this kind of knowledge graphs. That's graphs with the nodes representing some knowledge space elements and connections between them reflecting some interactions between those elements. So that's all, but I think they are more or less about the same. So they are trying to extract facts in computer readable way and use these graphs in order to traverse the network and understand the relationships between different nodes in that network. So we decided to start with the same language, and this is the screenshot of the Bell editor implemented within the MPS. You see this, it may be similar to programming language, but it is completely different. For example, this line says that some modification of the protein, being in particular the abundance of the modification of the protein, actually causes some biological process. So the language itself is quite simple, but it may be used as a starting point. So we decided to do it. The language is packaged now as an RCP application. It has custom model persistence into the syntax of the Bell language. So what you see on the screen actually used as a storing format for MPS models. We use obviously projectional editing approach for editing that, and we using some intentions and other stuff to guide user through the entering the data. We do not use code generation, and we do not plan to use code generation in that project. This is just an IDE, or better say editor, nothing more. So we did that project in cooperation with GeneStack company and other pharma companies connected to us through the GeneStack. We first created Bell editor. It was quite easy to create it, quite powerful. in order to be more usable than existing Bell editors, because they use some forms or or textual editors or so on. We got quite good response from the field, and we realized that Bell is a good starting point, but it is not sufficient, because the Bell is quite well in covering some facts around protein genome processes and modifications and so on. But the problem is that the conditions where corresponding process was observed, or some macroparameters and other facts, are completely not covered within that language. They use just comments and textual syntax for that. So we decided that we should probably involve something better than Bell, and we call this language BTB. Yeah, the problem is that we just started with this project. We prototyping in different areas. So this language, I'm not able to show you anything in that area. This is our next step. We're going to create and create the first prototype of BTB and try it, and we will see how far it will go. So that's all about the language for entering the knowledge within the knowledge base, and let's move on to the query language. Query language is just our plans. We don't have any particular prototype for that. We would like to start with the prototype immediately once we have a more or less reasonable BTB prototype, right? We just can say something about the requirements. Probably there should be a DSL for entering the queries into the system. Probably this DSL should support some way of dialogue with the person. So you enter query, get some results, refine the query, get some results back, and so on. Probably there should be a query engine which will run quite sufficient computations. So it would be quite power consuming. We are thinking actually about involving some artificial intelligence technology in order to process the query or execute the query. It will. We don't know about that. We just think about these ideas, right? And yeah, as I said, we will start this prototype immediately at the moment we have BTB. Yes. Well, we are talking about the knowledge. We are talking about the knowledge base. Once you enter it, it is internally formed as a graph of nodes, right? But what you would like as a person is to understand if this protein abundance somehow affects this process, right? So you ask the question: do you have a connection between these two nodes? And this is actually what is in particular. It is something like that. It is actually related to the graph. Yeah, the Cypher stuff we already heard about today, and I was quite surprised that somebody else is doing something in that area. Great. So I mean, this is about querying the knowledge base, the graph, and specifying some conditions, so on. Yeah. So let me probably move on, and the next topic I mentioned was the environment or the infrastructure for actual person doing the experiment, for planning experiment and logging the data. So this is all about labbook DSLs, or better to say labbook, not DSL, but DSLs. The idea is that we would like to allow to create a plan of the biology experiment, log all the data, let user use this data for some conclusions, even more provide the assistance in those conclusions, so extract some high-level facts from raw data, if it would be possible, right? And as a result, we should probably introduce high-level knowledge facts into the knowledge base and trace it back to the experiment plan, in order to be able to hold this this information and revisit it in the future. So in the area of labbook DSL, I'm going to show you some screenshots again. So first screenshot is about ontology library. This is the DSL describing biology ontology. I don't going to say anything more about that. It's very simple, right? So the next screen is about describing system of units, notions, or measurement units. This is quite close to the embedded physical units prototype, and we actually think about, or will think about, using that prototype, that extension from the embedder. We prototyped our own DSL, but this is just for simplicity and for the time being, right? We again have physical units you see here, and we missing conversion rules, which probably is a part of embedder, and we should at that moment we will once again revisit the question of using physical units for that, right? Mhm. This is not connected to any language. This is just you see, we even place some enumerations and data types here, right? So it's kind of bench of all possible uh, types of properties. So yeah. Okay, then this is probably yeah, one of the reasons we. I will talk about that later. Yeah. So the next stop of my presentation is actually the place where you can define properties. Well, it's just name type property, but the important thing is that properties are not bound to any objects. They're just staying in the library, and we will bind it later, right? So that's all about common stuff. So actual experimenting person is not intended to modify all this stuff, because it should be just a generic library for him. This is the first screen the experiment should start with, or the future experiment should start with. Any experiment operates, to our understanding, with some samples. So we are defining samples. This is quite close to Java classes or concepts in MPS, right? You define a name, you import some properties from the library, you can define new properties in place here, and you may define references across the samples and references to ontology elements. So this is kind of definition of the type which would be used within the experiment, right? So the next screen is about actual task which experimenting person have to perform, right? So for example, this task is about extracting blood from a person who actually physically visit you, right? So we cannot automate this stuff. So we use still text. Right, right, right. So, by the way, in the biology experimenting space, some of the actions are fully automatable with machines, right? So it may be expressed as a script. But yeah, still, we use text in order to explain to the experimenting person what should be done here, right? But the important thing is that blood will have some blood sample would have some properties which are inherited from the input parameters, and this is the place where you can use expressions in order to specify this binding. We again implemented very simple expressions for that purposes, and again we should use kernel F, or revisit this question later once we come to the next step with this prototype, right? So that's all about the action. Once again, it should be performed by the experimenter manually, and we are close to actual plan of the experiment. So what does it mean, the plan of the experiment, right? Usually the person gets some number of input parameters, right, input samples, then perform several steps with those samples. Sample actually goes to the step as an input parameter, then is transformed to something else, and actually exited the step as an output parameter, and then again goes to the next step. So that's more or less the script describing how the experiment should look like. These square brackets around the persons means tables. Tables are mentioned here because usually biology experimenting persons, experimenters in the biology space, uses tables for logging their data. They are not using papers anymore, but they are using Excel. So the idea is that we would like to replace Excel with this stuff, right? So we specified a special type for table, some additional operations on top of that type, and actually the person may log the experiment completely using, again, the simple expression language. Once the experiment is planned, we may start it. And this is the screen about an instance of the experiment. You see that instead of the old persons, which was a table, we actually created a table with all the properties of that person. And there is a first step which was performed where we're extracting blood sample, and each blood sample has all the parameters filled in. On the bottom of the screen, you see intention menu with the perform step 2 action. At this moment, we will create new instance of the step 2. And actually, interpret all the expressions which were specified in the experiment plan of step 2 and actions referenced from that step. In the end, we will get some tables, again, with pre-filled parameters, and the only task for experimenting person is to fill in the values which are read. So that's, yeah? No, that's in better tables. But we interpret our own, implement our own interpreter. Sorry, yeah. So interpreter again, for the simplicity, was implemented by us. But tables, I will talk about that later. That's some better tables. Good question. So let me summarize it all. Logbook DSL prototype provides comfortable editing environment for guiding user with entering the data, right? Simple expression language, interpreter for this language. We are not using code generation. We don't plan to use code generation in that project. It's out of scope. This prototype has no type system. We just using scoping and constraint and concept typing in order to provide some type safety, so to say, right? And once again, underlying models may be used for future analysis of the data which goes outside of the experiment, extracting high-level facts from those data, and revisiting the experiment result and plan in the future, because it may happen that the experiment was wrong and the fact was wrongly derived, so we should revisit it. Okay, so actually now I'm going to talk about the lessons I personally learned, or the lesson I personally learned from this project. I participated in that project while we were doing it, and actually the lesson is we should use MPS for developing DSLs. So the slide is called X Reasons to Develop DSLs in MPS by MPS Team. Yeah, so first of all, positive feedback. You know that I was developing editor in the past in MPS, and now it's up to the Simon. But still, I do understand how the editor works internally and very well understand the structure and so on. But once I start using the editor, the current editor, I immediately mentioned that it is very powerful. I may do a lot of things with that, right? I may customize it anyhow I can. And I see the huge difference with the editor which was in the past in MPS. So this is the place and the moment when I just can come to the team and say, hey guys, you're doing a great job, right? So next, better understand DSL designer requirements. Well, that's about tables. That's my example, right? So at some point we realized that block-like representation of the structure is not sufficient for us, and we have to use tables. We have tables in MPS. Well, I sit and think about how to use these tables, and I realized that, well, I can do it, but the use case is very special. We have special node structure. It's not one-to-one mappable to any tables we have. Let's try to use embedded tables. And it took me a couple of hours, including building the embedded extensions and including that into the project in order to have the tables like that. It is cool. It is fast. It is usable. It is very good for writing your own DSLs on top of it, right? So yeah, using that. So actually, the conclusion is that we should use MPS for developing DSL in order to understand which particular cases are painful for DSL designers and improve them. So we are going to include embedded tables into the MPS distribution in the future. Find usability problems. You remember probably that Simon was talking to you about the completion trace. It's a good feature. It's very, very nice. You can use it for tracing from time to time if you need it. And I use that because I need that, right? But each time I use it twice or 3 times during the development of that project. I have to go to the documentation, find that there is no information about that feature. I go to the what's new, go to the conference page, locate the proper what's new for the proper version of MPS, and then I realize that the shortcut is Command-Alt-B. I mean, it should be much more discoverable than it is now, right? So we will think about that and make it more discoverable. Later, guys explained me that Command-Alt-B means that Command-B but with Alt. It's reasonable, but we should mention it somewhere, right? Okay. Submit bug reports. Obviously, we found some bugs, and we submitted them, and we will submit them in the future. And feature requests. That's the last item in my summary, right? The example is that. Again, from the editor language, you know that there is a select operation which you can use in order to change the selection within the MPS editor. You always call not.select. It's quite powerful. You may specify where to select, but first parameter is editor context. I usually use this select operation within the concept function, which has the same parameter in the first place. Why don't we fill it automatically? I mean, that's the feature request I can file about that, right? So that's all about my summary. And let me talk a little bit about MPS extensions in the end, right? So the situation is that MPS extensions were developed by Embedder team. Great job, thank you, that's good. They did a huge effort in order to extract MPS extensions from the embedder itself and put it into the GitHub, right? There is a repository with MPS extension, but that's not sufficient. We should include it into the MPS build, because I have a branch with a feature for this lab book project, which actually depends on MPS extensions, and I cannot commit into the master before the moment I have the infrastructure for building MPS extensions and extensions on top of that. So the next milestone for me actually is to put MPS extensions into the building infrastructure of MPS. That's it, I think. Let me move on. Yeah, thank you for your attention and questions and answers.